Hello and welcome back to another session of AVR120. We are going to be going over player movement, applying gravity, and jumping today. So let's dive right in. So we're going to bind movement to the W, A, S, and D keys. The forward and backwards movement will be on W and S respectively, and the left and right will be on A and D. So we want to move left and right along our x-axis and forward and backwards among our z-axis. And so if we're going to approach this from like the x-axis perspective, W would be +1 on the x-axis, or sorry, excuse me, A would be -1 on the x-axis, D would be +1 on the x-axis, W would be +1 on the Z, and S would be -1 on the Z as well. So we want to make sure that we are doing this locally on our player object, so we're moving relative to where the camera on the player is facing. We want to be able to move forward, but if we need to, if we're looking with the camera, we want it to basically if the camera's facing one way, we're going to move that way as we're moving forward, and so the camera won't like rotate independently of the player object. And then if we're moving, so we'll need to go ahead and create a first-person player movement script on the first-person player game object. So we'll go ahead and click the FPS player. We'll go ahead and add a component, and we will create a new script. And we will call this player movement. Okay, so double click into the script from Unity, and I'll go ahead and the first variable that we will create is a public character controller variable. And this will be a reference to our character controller component on our player object. We'll also create a public float speed called speed, and we will set this to 12 F. And then we're going to go ahead and create some inputs, getting some inputs in the update function here. So very similar to how we did the mouse look, and very similar just in general to the 2D movement as well. We are getting the user's input on an axis. So we'll go ahead and we will set this as a float since it's returned as a float. So float x, we'll set that equal to the input class, and we'll get the axis off that input class, and we will get the horizontal axis there. Okay? And we will also get the z value, right? So remember, I said, so for the camera one, for example, for the mouse look, we got the y value. And that is because we are looking up and down, and y is, the essentially up and down ray that's shooting out from the object. So when we're moving, however, we want to move forward and backward. So we want to move along that z vector, or the vector that is coming directly forward from the player. Okay, so we're going to get the player's forward input here along the z-axis, and we will call this the vertical axis as well. Okay, so now what we're going to go ahead and do, okay, is we want to set a variable, a vector3 variable called move. And we will set that equal to the transform dot right. So the right, the red axis, if you look says the red axis of the transform in world space. Okay, so that is the red. Like if when you press W, it's that red ray that's coming off of the object. Okay, and we're gonna multiply that. Remember, we're trying to move along the X, right? So this is for the X input. We're gonna multiply that by our X variable. So the input that we're getting from the user along the horizontal axes, we're going to multiply that by the transforms x vector, okay? And then we're going to add, okay, we'll get our transform and we'll get the forward vector. So that's the blue vector that's coming off of the game object when you press W. And we're going to multiply that by z. So z is the input, the forward input, okay, that we got here. Okay, and so that's how we're going to set up essentially a vector 3, which will point us in the direction, which will move us into the direction that we want to go. So we'll go ahead and the last thing we're going to want to go ahead and do here is we're going to call the move function, okay, off of the character controller. So remember how I said the character controller is something that Unity has provided us? Well, there is a move function, okay, on that character controller component, and it takes a vector 3 of motion. So we have a vector 3 right here, right? Um, so we're going to take that vector 3 and we're going to plug it in here, but we also need to multiply it by the speed because it's going to be really, really slow if we don't do that. So we'll go ahead and multiply it by the speed variable we created. So that's the variable up here. And then we'll go ahead and we will then multiply that by the classic time dot delta time, which again is the if we mouse over, the interval in seconds from the last frame to the current one. So basically the time between the last update function call. So we'll go ahead and I'm going to just comment this out so we have it. So X axis and Z axis player input. Transform dot right equals takes the direction the player is facing and goes right. So it's the remember it's that red vector on the player object. So it just if the player is facing somewhere with the camera, it's going to go to the right there. And then so the transform dot forward is that blue vector, and it's going to takes the direction player is facing and goes forward. And then ultimately we create a direction we want to move in based on X and Z movement. So the inputs, the X and Z inputs, the player's inputting, and then multiplying that by the transform dot right and transform dot forward. So, and the way the player is facing. And so this function, all right, is movement used in built-in move function on character controller using our move vector we just created and multiplies by speed and time dot delta time since last update was called to make it frame rate independent. Okay, so we have all of that set up now. We'll go ahead and minimize this and save. And we will play it now. And I think, oh, I didn't add my references, so that's why that's not working. So if we go to the player movement script, and you see I don't have the controller reference, so I just need to grab this character controller component and drag it onto the controller, okay? Into the controller slot. Likewise, you could grab the object, the actual FPS player object out of the hierarchy and drag it into that slot as well. So go ahead and save this now, and I will play it. And as you can see, I can move. And when I move and I move my camera, I move in the direction that my camera is facing, right? So pretty neat. Okay. And we can increase the speed or decrease the speed using this speed variable. So if you want to make it faster, you can jack up that number. Okay, so now we'll go ahead and use those environment assets that we've set up, or if we've downloaded, excuse me. So I'll go ahead and click into the environment here, and I'm going to add a rock because I want to go ahead and go to your desert environment here, go to prefabs, and then go to rocks. You have all these different rocks you can use. We'll take a large rock here, and we will move it up on top of the environment. And then I'll take a mid rock here and move it up in the environment as well. And then a small rock, put that here. And I will also go into the prefabs folder again and go and click house. And I'm going to grab one of these houses, okay? And I will grab this house here, and I can kind of rotate it. Maybe we'll just do 180 on the Y. And maybe I'll move it over here. And you guys can really just add what you like to your environment, right? So, I mean, if you click into this desert and prefabs, you have all these awesome prefabs you can use. You got vegetation. We could put some, palm trees in here. I can, duplicate these and just, add them all over the place. Da 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 da. And kind of create an environment that I like. I can add some more houses here. I can add another house over here. Rotate it. For the purposes of what we're doing, maybe we don't really need to do a lot of. We just need like one building or so. So I'll just have something like that. Can save it. And to keep organized, okay, I think you should put all of your objects, okay, you want to drag all of these underneath the environment. And what I would also go ahead and do, okay, and you'll see actually I don't have everything in my environment, right? Because everything that's under my environment's like almost indented, except for these two, so I could tell that these were not under my parented to my environment object. So I'm going to drag that in there. And I want my ground to, maybe I don't want to apply things to my ground that I'm going to apply to other aspects of the environment. So what I'm actually going to go ahead and do is I'm going to create an empty game object underneath the environment. So I can do that by selecting the environment object, empty game object, and I'll create another empty game object here. And I'm gonna name this to desert to ground, and I'll take all of this desert here, and I will just drag it under the ground object. And that way, I'm kind of keeping my stuff organized here. And maybe I'll make another. I can even organize it even further. I can create another game object underneath environment, and maybe I will put my objects in there, and I'll select all my palm trees, small rocks. I'll drag it under the objects, game object, and then I'll make even one more here, and I will empty game object, and I'll make that under the environment again, and I'll call these structures, like so, and I'll take these two houses, and I'll just drag it under structures here. And so now everything's nice and organized. I have ground, objects, and structures under my environment, and I can move all of these independently of each other. So I can move the ground over here if I wanted to, and I can move all the objects at the same time if I wanted to. Okay, and I'm just pressing Control Z to reset the position because I didn't want to move them. I just wanted to show that as an example. So I wanted to explain a little bit about the character controller as well. So if we go into the character controller and we take a look at the step offset, we set it to 0.7. So that was actually the correct value to initially set it to. But let's say I set it to like 0.2, right? So if this is too low, this will not allow me to climb an incline here. So if I go ahead and go back into if I go ahead and run the program here, okay, and I try to walk up this stairs, I can't, okay, and that's because my step offset is too low, and so it won't allow me to climb any stairs or really go over anything. I think I can go over this because it's curved. Nope. So I can't because my offset's too low. It won't let me climb anything. So I'll go ahead and set that back. So click the the FPS player object, and then go to step offset. Set that to 7. Um, click save, and that should allow me to climb the stairs now. In addition to that, you'll see that the slope limit was set to 45, and that's in degrees, so it's a 45-degree angle. And basically, that's the maximum slope angle with which your character can climb. So, like 45 degrees is the max that they're going to be able to climb. If it's above 45 degrees, you won't be able to climb that slope. But this 45 degrees should be fine for what we're trying to do here. Okay, so and then if I click play now, you will see that I can climb the slope. Okay, but what you will notice is if I walk off the edge of this house, I float. Okay, so I'm going to just do this one more time here from our scene view to show you what's going on. So go ahead and walk up the stairs. Let me zoom in here a little bit and focus on the player like so. And then you'll see that I am actually floating. And that is because we have no gravity applied. So we need to go ahead and apply gravity. I mean, while it's kind of cool the way he's floating, probably need to have gravity if we're going to make, things like jumping and FPS mechanics work. So we'll go ahead and do that now. So we will go back into our player movement script, double click into that, and from here we are going to add some additional variables. So we'll add a vector3 and call this velocity. And then we're going to add a float for the actual gravity, force of the gravity. And we'll set it to negative, I believe 9.81 was the one that I found was pretty good. Worked pretty well. We will save it. And let's go down to update now. And so in update, all right, we are going to add some additional code here. So we'll go ahead and we're going to take the velocities. We're going to take the velocity variable we just created, and we are going to get the y vector of that, and we are going to add our gravity and multiply that by, not plus, multiply that by time dot delta time. And so we want to apply gravity over time. So because gravity is a force that gets applied over time. It doesn't immediately happen. So for now, we'll take a look at this, and we will also need to add. So we'll go ahead and go back into that move function, and we will add. We'll pass into the move function we're calling off our character controller. We will pass in the velocity, okay? And we will multiply that by time dot delta time again. All right. So we should be all set here. So basically, what this is going to do here is on our Y, when we fall off the edge of something, it will apply this number here, okay, this gravity number, and multiply it by the time the last update frame was called. And since it's called every frame, it will apply very, very fast, and it will plummet us to Earth via this move function here. Um, so we're essentially setting up the additional, we're setting up the y value, and we're adding the negative number to that to kind of go down on the y-axis, and then we are plugging that into our move so that when we move and then step over an edge, it will apply that velocity to our y. Okay, so if we go ahead and go into back into our game here. Okay, if I play it now, all right, you'll see that I now um, fall off the edge. Now it is instantaneous, right? The force gets applied almost instantaneously, and that is not what we want, because that's not how gravity works. Gravity is applied over time. It's not all, the entirety of gravity isn't applied in the immediate moment you step off an edge, right? You gain more velocity, you know, if you're falling off a building or something. Not that, let's hope that never happens. But if you were to fall off a building or drop an object off a building, it builds velocity as it falls down the building. So it wouldn't reach its max speed immediately. It takes longer for it to do that, as gravity gets applied more and more. So, um, what we need to do now is essentially set up um, a ground check on our player to see if he is on the ground. And if he is on the ground, we will then be able to do a couple things here. We'll be able to um, apply a velocity at a smaller rate over a period of time so that it doesn't get all applied at once. So that's kind of a cruddy explanation, but I'll show you through code and we will step through it. So we'll go ahead and click into the player and click into the player movement again. And now we're going to create some additional variables. So we'll go ahead and create a um, so I like to keep all my references together. So I'm going to put this underneath our character controller. And this is going to be a public transform ground check. Okay. And we're going to create a public float. And this is going to be called ground distance. We're going to set this equal to 0.4. And we'll go ahead and create a public layer mask, okay? And we're going to create something called a ground mask. And then all of our variables are here. So I'm going to add another variable. And this is going to be a bool, and it's going to be called is grounded. And I'm actually going to set this to public so that we can see it in the editor. Though we probably don't want to like manipulate it from the editor. We just want to see what the value is when we're running it. I know this ground check can be a little tricky, so just make sure you're following along like closely while we're doing this. So we'll go ahead and in our update function here, we're basically going to the first line. We're going to do we're going to check if we are grounded. So um, we're going to set is grounded equal to, and we're going to access Unity's physics. Um, so you'll see it says global physics properties and helper methods. So we're going to access Unity's physics engine. We're going to call something called check sphere off of this physics engine. And so this returns true if there are any colliders overlapping the sphere defined by position and radius in world coordinates, okay? So basically what's going to happen is that it will create essentially a sphere that is coming from our player. We're going to create a empty game object on our player called ground check. It's going to generate a sphere from that position with a certain radius that we indicate. And it's going to check against the layer mask that we are indicating as well. So this will make a lot more sense when we actually set it up in the editor too. But trust me for now. So we'll go ahead and we are going to take the check sphere and we're going to pass in. So for the position, we're going to pass in the ground check. So that's going to be the empty game object we put at the bottom of our player to check for the ground. And it's going to take that position because it needs to take a position, a vector3 position, right? We're also going to go ahead and pass in our ground distance variable, okay? So that is the radius basically between the empty game object, or it's going to be the length essentially of the empty game object from the ground. And then we're going to also pass it the ground mask, um, layer mask variable. So it's going to be checking the ground mask variable here. All right, and so the radius, all right, so it takes a radius, right? It takes the position where we want to generate the physics check sphere from. Okay, it will create a sphere from the ground check. Uh, it will essentially make that sphere 0.4 f large, and it will check, and whatever it hits first, it'll check to see if it's on the layer that we indicate in the editor. Okay. So as I said before, we're also going to make it so that the velocity doesn't get applied all at once. And so to do this, we're going to say if is grounded. Okay, so if we are grounded and our velocity on the y is less than 0, okay, right? So that means that we are mid-fall, or not mid-fall, but we've begun to fall, all right? If that is the case, then I don't want to apply all of that force at once, and instead, what I want to do is I want to subtract 2 from that force. So we're going to subtract 2 from the downward force that gets applied every frame, essentially. After, so it's going to say, so if we're grounded, so if we're on the ground, and our velocity is less than 0, so we're not falling, then apply this force um, as we fall. And so we'll go back in here, and we see that now back in the editor, we have this ground mass variable. So um, essentially what we're doing is we're going to take the reason that we set up our environment, right? Besides it kind of looking nicer in the hierarchy and be organized, is that what we can do is if we have multiple objects as a child of something, so for example, our ground, we can actually define a layer um, for those for that object and therefore for all of the objects underneath it. Okay, so a layer up here, okay, is essentially something we can use to apply um, to check. It's something that we can use to apply to multiple game objects that essentially we can use to check against in our script. So for example, here what we'll go ahead and do is we will add a layer, and we'll call this layer ground. Okay, and we'll click the ground object, and so we've just created the layer by clicking the add layer. We haven't added it to our ground object yet, so we need to reselect the ground object, go up to layer, and then go down to ground now. And it'll ask us, do you want to set this layer for ground and for all the child objects as well? And yes, we do. That's exactly why we've set it up this way, is so now that we've set ground to ground, our desert is ground, and so is the other objects, okay? I'm also going to go ahead and set our structures to ground because we want essentially it to be treated the same as the ground because we're going to be walking off the edge, and we want it to apply gravity when we walk off the edge, and to check if we're on the ground. So go ahead and apply that as well. Double check and make sure. Yep, all our objects are on the same ground layer. We will save it now. And let's go back to our player here. And so we are missing a few things here, right? So we're missing the ground check object. So we need to go ahead and on the player, we will right click and we'll create an empty game object again, okay? And we will call this ground check, okay? So select that object, and we don't want it to be in the middle of the player, okay? And that's because obviously the it would be floating. The player would never be grounded. So we need to have it more towards his feet. So we're going to move it down here, kind of right at his feet here. And I'm just going to make sure, get in close, kind of take a look at it, and, try to get it pretty close to his feet, like so. Okay. And then I'm going to just take the player and I actually moved, the player was up a little bit. I just moved them down. I want them to be like almost like touching the ground essentially when it starts. And I will save this now. And then on the player, we will take the ground object, okay, as we can see right there. We will drag this ground object into the ground check slot here. So your ground check object, excuse me, into your ground check slot. And then for the ground mask, this is what we're going to be checking against. So it needs to not be nothing. We want to set this to ground. And so that will allow us essentially to tell the code, hey, this is what I want. Everything on this layer, on the ground layer, means that this is grounded, will be true. So we'll be on the ground. And so just to reiterate one more time, and here is some documentation, tags and layers, okay? You can find this in the Unity documentation, but tags are really for specific game objects, and you can do checks on them. We'll set that up in later lessons. And then sorting layers are what we just set up. We set up a layer. We set up, and that allows you to group objects that share create a group of objects that share particular characteristics, and then we can use those to run code or do what we need to. Okay, so we'll go ahead and the other option too is if you wanted to set everything as ground, you could just click the environment object, and we can just literally set that to ground, which I think I'm going to do here, so that we can jump off everything if we need to. Go ahead and press save, and we will run this now. And I'm just going to drag this over. We'll see here that can go up the stairs, and then when I fall off gradually. I don't immediately have my force applied. So I'm going to just drag out the game window to my second monitor so you guys can see. If I go back and go on top of the building now, I fall off more gently down to the earth, and you can adjust the gravity, right? You can make this less and it will fall faster. So if I set that to like 5 or something, you know it will have more it will push down more, um, a little faster, right? A little less floaty. Okay, so we've set up our ground check there. And so now we can essentially use that to jump. and create a jump situation. So we'll go ahead and um, go into our movement script here. And now we'll go ahead and create another float here. Public float jump height. And I'm not a big fan of how this is organized, so I'm just going to I mean, it doesn't matter where you declare variables. So, well, let me rephrase that. It doesn't matter what order you declare them. Um, so I'm just going to group all my floats together and my bools and then velocity. Um, I just for organization purposes. Anyways, so I've created a jump height. I've set it to 3F there. Okay, that's what we just created. And then I'll go down into my update function here, and I will create an if check, and I will say if input.get button down. All right, so you might remember this from our 2D tutorials, but basically that is the Unity input system. We're calling the get button down method, okay, and we are using a string. The get button down method takes a string, and we just indicate the button name we want to use, so we want to use jump, okay? And so there is a jump button that's default in Unity here. So we'll go ahead and let me just, I'm going to make curly braces so I'm not getting errors. We're going to return this in a second here. I just want to show you where those inputs are. So we'll go ahead and go up to edit and project settings, input manager, and open up these axes here and down to jump. Okay. And we'll see that the name is jump. All right. So we're passing it that variable, telling it, or that string telling it, hey, we want to use this input here. And we're going to, the positive button is space. Okay, so it's our space bar. That's short for space bar. So if you want to switch this to something different, I mean, you could set this to like F or something, or something different there if you want. I'm going to leave it as space bar. Um, so we'll go back to our code now, and we will basically so if the user is entering that input and they are grounded, okay, then I want to take the velocity, the y component of the velocity vector 3 we created. So the y component of the force that we are applying to the character on the y-axis. And so this is kind of, we just need to use the square root function. I mean, there's not much explanation for that, but we're basically squaring the jump height. We're squaring this next equation here. So we're just going to take square root, returns the square root of whatever is inside of this function, and we're going to pass that jump height, okay, which is a float, all right, which is set to 3F. We're going to multiply that by negative 2F, all right, and we're going to multiply that by gravity, okay? We'll go ahead and save this now. And we will go back to the editor. Well, just want to make sure okay, this looks good. I'm going to go ahead and press play. And we'll see now I can jump. So it's, floaty, but you can adjust the values if you want it to be less floaty. I kind of like the floaty jump. And yeah, so I guess we could see what jump height of 1 is. little bit smaller. But yeah, so that will do it for this session here. We went ahead and added gravity, jumping, and movement. So we did quite a bit. Definitely if you're having some errors, common errors I know people were running into in the class, make sure that you have your references set up correctly, particularly that you have the ground check on your player and that you set that reference up in the player movement script. Make sure that your environment you've set to the ground layer so that the ground check is working. And then, yeah, just review the code, make sure all that's all set, make sure the ground mask is set in the player object. Those are pretty common errors. Other than that, one more thing I did want to mention too that was a common error I saw was make sure you're actually doing this in this order. So remember, code runs in a line, runs each line and it runs downwards in that sequential order. So um, if, for example, you have this, before this, it's going to cause issues. So just make sure that you've kind of done the code in this order, followed along there. Otherwise, you might run into some issues here. Okay, so we'll go ahead and finish out commenting this code. So this line here, what we're doing is we are setting the the y of the vector 3 velocity, y transform, and we are, sorry, we should say taking velocities, y transform, and adding gravity every frame, essentially adding the gravity variable value every frame. Then here we are applying this movement to the player so that when he falls, velocity is added to his transform, simulating gravity. Up here, we are essentially saying this will create a sphere at ground check. Oops, sorry. Ground check position using the radius specified in ground distance variable, and will check any game objects specified in ground mask layer. If it finds something is grounded, equals false. Sorry, is grounded equals true, because we are checking to see if there is ground. Okay, and then the if check's kind of self-explanatory, but we're going to basically what this is going to do here is it resets the player's velocity to -2 at the start of each frame, so that the gravity doesn't keep getting added and make the force being applied to the character on the y-axis immense. Uh, this is because the force would be applied every frame. So the gravity, right, is going to be applied every frame to the character's y or vertical vector, and because of that, and because of how quickly, since frames in a game is going to be called, there's like 60 frames in a second, right? Uh, it will all be applied very quickly, almost immediately, and plummet the character down to Earth. So we need to reset that value to -2 to just keep it small enough that we'll keep adding this force, but it doesn't essentially happen. It doesn't like apply a huge amount of force immediately. Okay, so um, go ahead and just make sure you have all this code here. Appreciate you guys listening in. Know this was a little bit long and involved. If you have any questions, let me know. Otherwise, have a great rest of your day. We'll see you in the next session.